Alright, so today's lesson is about solving exponential equations. We've done a lot of work simplifying them, finding different ways to express them, and sort of we're learning the rules and the ropes, and now we're trying to actually use equations to solve. Now, when you solve an exponential equation, okay, we are going to heavily rely on this property right here. This property states that if a to the power of x is the same number as a to the power of y, then x must be the same as y, as long as a is not 1 or 0 or negative 1. Okay? So this is a really, really important idea. The goal of a lot of our work in this lesson is to make the bases the same. That is what you are trying to do. So like when you look at this one here, 2 to the power of x equals 8, that would be very easy to solve if we remembered that 8 is 2 to the power of 3, and therefore 2 to the power of x equals 2 to the power of 3, and therefore x equals 3, right? So you see, I change the 8 into a power of 2, and then I can see that the two exponents are the same. So a lot of the goal here is to make the bases the same. If the bases are the same, the exponents must be equal. Okay? So here's a really good one just to get us. I think today we can just jump right in. There's not a lot of theory. It's basically the whole thing is about how do you write two things using the same base. So for here, for example, right? What I'm going to do is I'm going to replace with 9 with 3 squared. Okay, therefore 9 to the power of x plus 1 becomes, right, becomes 3 squared. So instead of 9, I wrote 3 squared, right? And then I raised this to the power of x plus 1. Okay, and then what you can see here is you can use your exponent rule. We go 3 to the power of 2x plus 2, because when you're doing an exponent to another exponent, you multiply. And then you look at the other side of the equation now, and you get 3 to the power of x minus 1. Now that I have this, they're both the same base, and I come to this really important step where I just drop the two bases and I look at the two exponents. X plus 2, excuse me, 2x plus 2 must be equal to x plus 1. And you know how to solve this. All we're doing here is just we bring this x over and bring the 2 over, and we get x equals negative 3. And so this would be solved when x is equal to negative 3, and you can go back and check that, right? Let's just quickly check this so you can see it. So on the one hand, I'm going to draw 9 to the power of x plus 1. On the other hand, I'm going to draw 3 to the power of x minus 1. Okay, now of course, finding out where these two cross is very difficult to look at, because you can see that the blue is never going to catch up to the red. So we have to look for an answer over here. Let's look for an answer over here. And of course, to do that, we have to really zoom in quite a bit. So let's just stretch things way up. Right, and now you can kind of see, okay, finally I've stretched it up enough that the two cross each other, right, at this point when x is equal to negative 3, which is the answer that we got, right? So this equation is equal to that equation when x is equal to negative 3, and you know we could check f of negative 3 and g of negative 3, and we get they're both equal to 1 over 81, right? So we've solved the equation. So that's what the check part is. So to check, right, what we do is we do 9 to the power of negative 3 plus 1, which is 9 to the power of negative 2, which is 1 over 81. And then we do 3 to the power of negative 3 minus 1, which is 3 to the power of negative 4, which is also 1 over 81. So we've checked and we know that the answer is right. Okay? Let's try another one. So this one says 4 to the power of 2x minus 1 is 1 over 64. So it would be nice if we could think of some way to write 1 over 64 equals 4 to the something. Now what is that something? Let's think about powers of 4. You have 4, 16, 64. So that's 4 to the power of 3. So 1 over 64 is 4 to the power of negative 3. So now our question becomes pretty easy. 4 to the 2x minus 1 equals 4 to the negative 3. And we just solve. 2x minus 1 equals negative 3. So 2x equals negative 2, and x equals negative 1. Okay, and that would be the solution to that one. So again, I'm not going to, as a check, let's just use GeoGebra to check rather than sub in. But so here you go. So 4 to the power of 2x minus 1, and then 1 over 64. Let's draw a line. Y equals 1 over 64. So we'll draw a flat line. Now again, the solutions in the negative region are always going to be really, really small numbers. So a lot of the time you got to sort of stretch your answer quite a bit just to see them. But you can see there is a solution, and it's located exactly when x is equal to minus 1, which is what we said. Okay, now these can get more or less complicated. Let's try a couple more. So here you have 2 to the power of 2x plus 2 plus 7 equals 71. Now again, don't forget your other algebra rules here, right? It's simple in this case to just move that 7 over to the other side. And when you do that, you get 2 to the power of 2x plus 2 equals 64. Okay, and 64, if memory serves, 2 to the power of 6 is 64. So we could say 2 to the power of 2x plus 2 is equal to 2 to the power of 6. Therefore, 2x plus 2 equals 6. Therefore, 2x equals 4. Therefore, x equals 2. So let's write this one. So I'm going to draw the equation. Y equals 71. And then 2 to the power of 2x plus 2 plus 7. So I'm going to draw that equation. So I got two equations here. And I can see they cross each other when x is equal to 2, which is what we said. Okay? Now here's a good one. 2 to times 4 times 8 equals 128. So let's just remind ourselves powers of 2. Okay, so let's make some powers of 2 here. So we need to go up to 8 or so. I forget, but anyway. Okay, so 2 to the 1. 2 to the 2. Oops. 2 to, sorry. 2 to the 3. 2 to the 4. 2 to the 5. 2 to the 6. 2 to the 7. 2 to the 8. 2 to the 9. 2 to the 10. So just some powers of 2 to help you here. 2 to the 1 is 2, then 4, we double it, we get 8, we double it, we get 16, then 32, 64, 128, 256, 512, and then 1024. So you might find this table useful when you're doing this kind of work, just because now you can kind of look at this and we can change all these other numbers with powers of 2. Let's change them all with powers of 2. The 2, obviously, I don't need to do anything. It's already ready the way it is. The 4, I'm going to replace with 2 squared. And then it's going to be raised to the power of 2 minus x. Okay? The 8, I'm going to replace with 2 to the power of 3. And then it is raised to the power of x plus 1. And then the 128, I'm going to replace with 2 to the power of 7 to the power of x. Okay? Now, what the advantage of what I just did, okay, is that now everything is in a power of 2, and now we can just sort of expand some of this stuff, and we'll see what we get. So 2 to the 2x plus 1, nothing I need to do there, that one's already ready. In the next bracket, I need to multiply the exponents together, so I get 4 minus 2x. In the next bracket, I need to multiply the exponents together, so I get 2 to the power of 3x plus 3. And in the final bracket, I need to multiply them together, so I get 2 to the 7x. Okay, so you see it looks a little bit simpler than it did above. Now, on the right side, I can change this all into one huge exponent if I add the exponents together. So I've got that plus 4 minus 2x plus 3x plus 3 equals 2 to the power of 7x. Okay, so you see what I did there? I used my exponent rules. I'm multiplying powers with the same base, so I add all their exponents together. Now what I can do is I can drop the basis. I can go 2x plus 1 plus bracket 4 minus 2x plus 3x plus 3 equals 7x. Again, that bracket that I drew there really isn't needed because the the positive number is 4, the negative number is the 2x. 7x, so I get this. So let's collect some like terms here. 2x, take away 2x, plus 3x leaves me with 3. Then I have 1 plus 4 plus 3 is 8. 7x. So let's bring the 3 to the other side. 8 equals 4x, and x equals 2. Okay, so there's your solution to that question. Again, let's take a second to check this one. I'm not sure what the graph will look kind of strange with 128 to the power of x, but okay, so that's one function. The other function is 2 to the power of 2x plus 1 times 4 to the power of 2 minus x times 8 to the power of x plus 1. Okay, so that's what we have. And we said that the two of them should cross each other. We should be looking for our solution. Right, you can see there's a solution right there when x is equal to 2, which is exactly what we said. Okay, this is a really good one to try. I think if you can do this one, you're in good shape. So again, maybe pause the video, go back and try and do it yourself. Okay, so just a couple more, and then there's some extra practice here, and I believe there's also an assignment related to these ones. So let's try the last couple. So I'll do them all today. I won't leave you with any because there's a whole bunch of practice work at the bottom. And I'll open a discussion area if you want to post any of these ones. Some of these ones are really, really good. Just challenging ones that if you can do, then you know that you've got this down. Okay, anyway, this one. I need to write everything as a power of 2. So let's go back to my handy chart and find out what 16 is. 16 is 2 to the power of 4. So let's rewrite it as such. So 2 to the power of x squared equals 2 to the power of 4, okay, to the power of x minus 1 times 2 to the power of x. Okay, so now everything's in terms of 2, so that's good. On the right side, I want to join these things together. So I get 4x minus 4, and then I'm going to add the other x, right? Because that other, you have to add exponents. So you multiply the 4 and the x minus 1, and then the other x gets added because you're multiplying powers of the same base. So what you get here is that x squared equals 4x minus 4 plus x, and therefore you get x squared minus 5x plus 4 equals 0. Okay, if you bring everything over to one side, this is a quadratic. You can factor it with x minus 4 and x minus 1, since those two numbers add up to -5 but multiply to positive 4. Therefore, our solutions are x equals 4 and x equals 1. Now, these ones, especially when you get two solutions, really you should do this all the time, but especially when you get more than one solution, check to make sure they work. Sometimes you're going to get an answer that doesn't work. Okay, so I'm just going to put that in red. Let's check to make sure these ones work. So let's sub in x equals 1 first. So on the left side, we have 2 to the power of 1 squared, which is simply 2, right? It's 2 to the power of 1. On the right side, we have 16 to the power of 0 times 2 to the power of 1. And that, of course, would be equal to 1 times 2, which is 2. So this solution works out. This solution is accepted. It worked on both sides. Okay. The other one, we have to check x equals 4. So 2 to the power of 4 squared, which is 2 to the power of 16, which is a number I do not know off the top of my head. 2 to the power of 16. Oh, I should have known that. That's if you play any Nintendo games, you would know that this is the largest number that a Nintendo game can generate. Anyway, I don't need to go down this rabbit hole, but anyway, because of the way computers store information, I should have actually known that number, but never mind. On the other side, okay, on the other side we have 16 to the power of 4 minus 1. So we have 16 to the power of 3 times 2 to the power of 4, right? So that's what we have on the other side if we sub in x equals 4. So 16 to the power of 3, times 2 to the power of 4. Let's check what that is. So 16 to the 3 times 2 to the 4, and we get the same answer. So I'm going to accept this solution as well. So again, both answers work here, but be careful that sometimes they don't. So just again, be in the habit of checking that they work. Okay, let's try F. Again, a 9 and a 27 and an 81. This question introduces a new type of problem. Okay, if we look at powers of 9, you find that 9 to the 1 is 9, 9 to the 2 is 81, and 9 to the 3 is 729. Now notice 27 never came up, right? So it seems like I can't use 9. Now, if you're really clever, you actually can use 9, because it turns out that 9 to the power of 1.5 is 27, right? Let's test it, right? So you can use all 9s in this question if you want. I'm not going to solve it that way. However, if you want to, you're free to do that. What I would suggest you do in this question, instead of working with 9, is ask yourself, what is an even simpler number that I could use that uses all of these that all of these numbers go into? And that number is 3. I can actually write everything here in terms of 3, because 3 to the power of 1 I don't need, but 3 to the power of 2 is 9, 3 to the power of 3 is 27, and 3 to the power of 4 is 81, just for your reference. 3 to the power of 5 is 243, in case we need that later. Okay, so you can use 9s to answer this question. I challenge you to do so, but I think a better habit to be in is to use the 3s. Okay, so let's rewrite the question again, replacing all the numbers with powers of 3. Okay, then we have that one over 3 to the 3 to the power of x minus 1. Okay, and then on this side we have 3 to the 4. Okay, so now what I'm going to do, I'm just going to multiply the exponent times the exponent on the top to get 2x plus 8. Okay, on the bottom I have 3x minus 3. And on the other side is already ready. Now, to make the left side a single power, I'm going to take the 2x plus 8 and I'm going to subtract the 3x minus 3. Again, I would suggest using brackets there so you don't lose track of that double negative. Let's subtract. 2x take away 3x is negative x. 8 take away negative 3 is 11. Oops. Okay, and so you come to the conclusion that negative x plus 11 must be 4, since they're both powers of 3, and therefore x equals 7. Okay, so that's my theory for the answer to this one. Let's draw it and check. Okay, so I'm going to draw y equals 81. So that's the first equation, y equals 81. That's the right side. The left side is 9 to the power of x plus 4 divided by 27 to the power of x minus 1. And you can see that they do cross each other. Where do they cross each other? Let's have it find out for us. They cross each other when x is 7, which is what we said. Okay, when x is 7. Okay, so again, excellent question. Remember, you don't have to use a base that's in the question. Maybe all the 3 numbers can be put in terms of a simpler base. Okay, now we get to the really challenging ones. Now these last two, okay, are a different level of challenge than the ones that come before it. And the reason is because you cannot use an exponent rule for a to the b plus a to the c. It's not equal to anything. You cannot use an exponent rule to add powers. Okay? This is a common mistake. So if you're looking at this question and you're wondering why is this harder than the one above it, the one above it, everything was multiplied. Everything was multiplied. I mean, the exponents had addition, but I mean here there was addition, but we dealt with it. We moved it to one side and got rid of it, right? Even the hard one with 9, everything was either multiplied or divided. Now in this question you have adding. And there's no simple way to deal with the adding, because if you send it over to the other side, you still have adding on the other side. So here's how you solve this question. When you have adding or subtracting powers, try to factor. Okay. Now this is again a little difficult to do, so try to follow this part. If you need to rewatch it, then rewatch it. Do it with paper. Let's remember, what are we doing when we factor? When you factor, let's factor something simple. Let's say you were factoring 3x plus 6x squared. Now you're so good at this, you probably do it in your head, but just to clarify what you're actually doing, you're pulling a 3x to the front, then you are taking each term and dividing it by 3x. What happens is you get a 1 plus 2x left, right? Now I know all of you can do that, but I bring it up because when you factor with exponentials, it's helpful to remember this format. So let's factor the first two. We have 2 to the power of x plus 2. Okay, so 2 to the power of x plus 2 minus 2 to the power of x plus 1. Now, what is the greatest common factor there? The greatest common factor is 2 to the x plus 1. What happens when you factor it out? So let's do it the way we did above it. 2 to the power of x plus 2 divided by 2 to the power of x plus 1 minus 2 to the power of x plus 1 divided by 2 to the power of x plus 1. Okay, so just like when you were factoring, you divide every term by the common factor. That's what I'm doing here, dividing every term by the common factor. Okay, now what happens when I do that? On the outside, I get 2 to the x plus 1. That's easy. What's left over inside the bracket, though? Well, if you subtract these things, you get x plus 2, right? Take away x plus 1. And on the other side, of course, you just get 1 because 2 to the x plus 1 over itself, you just divide through and you get 1. Okay, so let's do the subtraction. 2 to the power of x plus 2 take away x plus 1. Okay, so x take away x is 0. 2 take away 1 is 1. So you actually get here 2 to the power of x plus 1 times 2 take away 1, which actually all simplifies to 2 to the power of x plus 1 by itself. Now that is a very, very, very strange idea. Think about what I just did. I took this, which is a subtraction, and when I factored it, I just got a part. I just got the 2x plus 1 with nothing, right? Very, very odd. Let's graph it, right? So just so you can see what I'm talking about. So here's 2 to the power of x plus 2. Take away 2 to the power of x plus 1. Okay, so that's what I'm saying. Now again, let's have GeoGebra factor. If I could find my O key, factor h. Okay, it actually isn't very good at this. It doesn't know how to do it, so I guess we have to learn. We have to know how to do it. When I factored it, I came up with this answer: 2 to the power of x plus 1. Now look at the curve. It is the exact same as the original. Now, how does this help us? Well, what I just did here is I took the left side of your equation, right, which is this thing, and I was able to simplify it down to just one term. So now let's make the equation again. 2 to the x plus 1 equals 2 to the 6. Therefore, x plus 1 equals 6. Therefore, x equals 5. Okay, so let's check this now. So get rid of this. Get rid of this. Okay, so I want to go y equals 2 to the 6. So there's the line. Where do they cross each other? They cross each other at exactly at 5, right? Where we predicted. So when you see addition or subtraction of powers, you have to think, I got to factor this. I can't use an exponent rule for adding and subtracting powers. We don't have such a rule. Okay, let me do one more, and you'll see how this one's a little bit different. Okay, this is I think this is like a good question for this is like the final application question on the test in terms of difficulty, right? So like getting this would be people, you know how I said in application you're going to get if you get 1 right, you get 75, 2 right, you get 87.5, 3 right, you get 100. This would be the how do I get 3 right type of question. So how do I do this? Again, I'm going to look at the left side, minus 3x, and I'm going to factor. So I recognize right off the bat, I recognize a subtraction of powers. I know I need to factor. And let's qualify this a little bit. Factors of the same base. I know I need to factor. Okay, so what I'm going to do is I'm going to look at this and I'm going to try to factor it. So what is the biggest common factor in both of these? Is 3 to the power of x. Now I'm going to take the first term and divide it by 3 to the power of x. And the second term, of course, is just going to reduce to 1 because it's 3 to the x over itself. What happens here? 3 to the x. Now, in the middle bracket, okay, you get 3 to the x plus 2, take away x, right? When you do the division. So you get 3 to the x on the outside. On the inside, you get 3 squared take away 1. So you get 3 to the x, and then you get 8. Notice how, because 3 squared is 9, notice how instead of 2 terms, I now only have 1. And that was the same sort of magic that happened above, right? Where I started with 2 terms, but after I factored, I only had 1 left. Same thing happens here. This whole original thing can be replaced with this, and let's just prove that by drawing them. Okay, so I have 3 to the x plus 2. And then I have, I have that take away 3 to the x. Okay, so that's what you've got there. And I contend that that is the same thing as 8 times 3 to the x. And if you look, they are, right? The exact same function. Bizarre, isn't it? We'll look into how this works a little bit better later, but it's amazing to me that you can subtract 2 functions and then replace it with just one term only. But anyway, it does work. So we get this. So now what we see is that 3 to the x times 8 equals 216. Let's get that 8 over to the other side. So 216 divided by 8, that is equal to 27. And now you can see 3 to the x is equal to 3 to the 3, and therefore x must be 3. Okay, so again, let's just check my answer here. So I'm gonna here's the function I drew. I want to check when is it equal to 216. I'm going to go intersect f and h, and it intersects when x is 3. Okay, so again, not a super difficult question when you know what to do, right? But you got to know what to do, and you got to recognize that, like, this is a subtraction of powers, which means I got to factor. So review how to do this. Okay, I believe there's a couple of questions on here that will help you with this. Like, let me see here. 11, right? My page is kind of cut off, but let's just make this its own page. Okay, 11 here would be really good practice if you want to try these ones, because you notice in 11 they're all addition and subtraction of bases. So anyway, try as much of this as you can, right? Please post your solutions. I'm going to open an area for just again, it'll be pretty full. But just, whatever, do 5 of them and post the 5, or tell us which 5 you did and post them, right? Or, do more of them, right? If you really want to excel in this unit, do all the ones from 10 and 11, or do all the ones from, the second half or something. Okay, anyway, any questions, please post, and if you do solve any of those ones, please share on the website. If you're having trouble solving one of them, post to the website. I'm happy to help you.